Hi, welcome to part 1 of notes 1.6 and 1.7. These are the final notes for the first unit of geometry. Yay! We're going to begin by talking about polygons, and as always, we're going to begin with vocabulary. So, a polygon is a closed plane figure with 3 or more sides. Closed meaning that all of the line segments intersect with each other. Plane meaning that it lies within a plane. And I'm pretty sure you know what 3 or more sides means. Those sides are line segments. If they are line segments, that means they're straight. So there cannot be any curved sections of your polygon. If it's got curved sections, it is not a polygon. Vertex is the point of intersection of 2 sides of a polygon. And we have 2 kinds of polygons. We've got convex and concave. A convex polygon is a polygon such that no line containing a side of a polygon contains a point in the interior of a polygon. And concave means that it does contain a side with a point in the interior of a polygon. And let me draw you a picture and show you exactly what I'm talking about. So here I have a convex polygon, and if I extend one of the sides, if I could draw straight lines, then you will notice that no matter which side I extend, it's not going to go through the inside of the polygon. However, in this star, which is a closed plane figure with 3 or more sides, so it's a polygon, if I extend one of the sides, it goes right through the interior of the polygon, which means it's concave. And so, you know, kind of you can think if it's got any kind of indentation in it, that makes it concave. But the definition is that if I extend a side, it goes through the inside of the polygon. More definitions. We have n-gon, which is simply a polygon where n is the number of sides. We have specific names for polygons up through about 12, and then beyond that we'll start calling it a 13-gon or a 478-gon. Equilateral polygons are polygons in which all sides are congruent. Equiangular polygons are polygons in which all angles are congruent. And then regular polygons are convex polygons that are equiangular and equilateral. And this word regular, it's such an ordinary word, and we use it all of the time, that we don't understand that it has a very special meaning in geometry, and it's the key to solving many problems. You've got to pick up on that word regular. Looking at these 2 figures, I want you to think about in your head whether they are convex or concave, and whether or not they are polygons. So this guy right here, convex or concave? You can yell it out loud. No one's listening. You are right. It is convex, and it is a polygon. Is this guy a polygon? No, it is not a polygon because it has a curved side. Okay, you guys don't have this in your notes, but these are important. We name our polygons by the number of sides. So what's a one-sided polygon called? It's not, because it's not a polygon. How about a 2-sided polygon? Still not a polygon. 3-sided polygon? Triangle. 4-sided polygon. Oh, you want to say square, don't you? But we're going to go with the most basic form, which is quadrilateral. 5-sided polygon? Pentagon? 6? Hexagon? 7? All right, heptagon, although I'll also accept septagon. 8 is octagon. Stop signs are octagons. I'm going to need you to remember that towards the end of 2nd semester, so just tuck that little fact away for you. 9-sided, nonagon. 10-sided, decagon. Poor 11. 11 doesn't really have a name. We skip right over to 12. 12 is dodecagon, and then we already talked about the fact that anything else is just called by its number of sides, so we call those n-gons. Let's classify these polygons. So this one right here, if you count it all up, you'll find out it has 8 sides, which makes it an octagon. Also, these markings show that all the angles are congruent, which makes it equiangular. These markings show that all the sides are congruent, which makes it equilateral. And if it is both equilateral and equiangular, that means it is regular. So we are dealing with a regular octagon. All right, this guy right here, he's got 4 sides, but his angles aren't congruent, and all 4 sides aren't congruent. So it's neither equilateral nor equiangular, which means, of course, it can't be regular. So we are simply dealing with a quadrilateral. It might be a trapezoid, but we don't know whether these 2 sides are congruent necessarily, so we can't say anything about that. All right, this right here is, again, it's got 8 sides, so it's an octagon, and we are shown that all the sides are congruent. So we're going to go with equilateral octagon. Wow, I really can't write. Octagon. Okay, a square has 4 congruent sides and 4 right angles, which means that it is a regular quadrilateral. A rectangle is also quadrilateral, but it doesn't necessarily have 4 congruent sides. So we can only say, because of its 4 right angles, that it is equiangular. But it's still a quad. And then a triangle obviously is a triangle. If it has 60-degree angles, then 3 of them, all 3 are the same. We're going to go with equiangular triangle. And we've got a word problem. We've got the head of a bolt is shaped like a regular hexagon. Regular, our old buddy. Very important. And then we've got 2 expressions that represent side lengths. And we need to find the length of the side. So we need a side length, and we need a perimeter of the top of the bolt. All right, well, if it's regular, it means that all sides are congruent. In particular, these 2 sides are congruent, and if they're congruent, we can set them equal to each other. So I can set 4x plus 3 equal to 5x minus 1, which means that x equals 4. But again, that's not my answer. I have to plug it back in. Either one's fine. So let's just go with this one. So I've got 5 times 4 minus 1, so 20, so 19. So a side length is 19 millimeters. And then how do I find the perimeter of any polygon? Hey, Mrs. Uken, you add up all the sides. Absolutely. So they're all the same in this case, and there are 6 of them. So it will be 6 times 19. This is my perimeter that I'm doing. And let me see, 6 times 20 is 120, so subtract 6 sixes from that. So we're talking about 114, right? So here we have a singles tennis court, which is a rectangle, and I need you to find the perimeter and the area. So pause the video and do that now. You should have gotten that the perimeter was 210 feet, and the area is 2106 feet squared. If we start talking about the doubles court, then the width changes by 36 feet. So please find the new perimeter and area. Pause. Okay, so my new perimeter is 282 feet. And my new area is 4914 feet squared. So pretty significant change in area. Now let's talk about circles. So we're asked to find the exact perimeter and circumference of the circle to the right. Well, perimeter and circumference are the same thing when you're talking about a circle. So let's just ignore the fact that they have asked about perimeter in both of these. And let's talk about this word exact. Exact means that we do not round. Let me say that again, because this is a critical concept and it applies to your entire rest of your high school career. Exact means that you do not round. This down here, to the nearest thousandths, that means that I go ahead and round. So what am I talking about specifically? I'm talking about pi. Well, we all know that pi is 3.14, but it's way more than that. I mean, pi, people have memorized pi out thousands of digits. People who have no lives and no friends and never date, but people have memorized it nonetheless. So pi keeps on going. Pi is irrational. It is a non-terminating decimal. Although, you know who knows the last distance or the last digit of pi? Chet Norris. Nobody else, however, knows the last digit of pi. So if I want to use pi as a number, that means that I have to round. Since exact means don't round, it means leave pi in your answer. All right, so if this is my radius, 2.45, then I know that my circumference is 2 pi r, which means that my circumference is 2 times pi times 2.45, which means 2 times 2.45 is, what is that, 4.9? So 4.9 pi meters. This is the exact answer. Now, when I start rounding to the nearest thousandth, I'm going to take that 4.9 pi, 4.9 pi, and I'm actually going to take and multiply 4.9 by pi in my calculator. There is a pi button on your calculator. You might have to push the second button to access it, so we're on the right-hand side. But that's what we're going to use because it has more digits than 3.14, unless you're told to use 3.14 specifically. So when we multiply this times pi, we wind up with, this is our circumference, 15.393, right? Tens, hundreds, thousandths, still in meters. So exact, approximate, not rounded, rounded. We're going to continue on talking about triangles. And we've got triangle JKL, and it's got these vertices. So let me see, J is at 1, 6, 1, 2, 3, 4, 5, 6. So there is J. K is out here at 6, 6. This is 1, 2, 3, 4, 5, 6. So here's K. And L is located at 3, 2. And now I'm going to pathetically attempt to draw straight lines. If you guys were using this smart slate, you would have trouble drawing straight lines too. But no excuses. All right, and we need to find the perimeter of triangle JKL, and it says us to give our answer in both exact and approximate to the nearest tenth. All right, so let's talk about exact first. Well, JK is pretty easy because I can just count 1, 2, 3, 4, 5. So that length is 5. But these two right here, because they are diagonals, I'm going to need to find their distance. So you can use the distance formula. Or remember back when we learned distance formula and I told you if you could turn it into a right triangle, you could use the Pythagorean theorem? Let's try that method for right now. So I'm going to make a right triangle right here with vertical and horizontal. And this is 1, 2, 3. And this is 1, 2, 3, 4. So for KL, I can simply do KL squared equals 3 squared plus 4 squared. And then I got to take the square root of that. All right, so basically KL equals the square root of 9 plus 16, which is 25. So KL equals 5. Good news. All right, let's talk about JL. So draw another right triangle. All right, this time I have 2 and 4. So JL squared, C squared, equals 2 squared plus 4 squared. So I'm going to take the square root of that. And so JL equals the square root of 2 squared is 4 plus 16. So I get 20. All right, I got to reduce that. Well, that is the square root of 4 times the square root of 5. Square root of 4 is 2. So 2 radical 5. All right, so if I want to find my perimeter, I simply add up all the sides. So I add 5 plus 2 radical 5. All right, in my exact form, I'm going to get 5 plus 5 is 10, but then I cannot add something without a radical to something with a radical, so I have to leave this as 2 radical 5. These are in units. So this is my exact answer. I know it's not pretty, and I know it makes you uncomfortable, but nonetheless, that is the exact perimeter of this triangle right here. Okay, so for my approximate, so now I want to know what P approximately equals, and that's what this little wavy equal sign means to be. It's ish. Okay, then I need to go ahead and multiply 2 times radical 5 and add it to 10. And so when I round that to the nearest tenth, I get about 14.5 units. Word problems. You are using a roller to smooth a lawn. You must have a highfalutin lawn if you need to smooth it with a roller. You can come over to my house and roll my lawn smooth. It's all weeds anyway. It says you can roll about 125 square yards in 1 minute. So that's kind of a rate, right? 125 yards squared per 1 minute, right? Like miles per hour, that's a rate. And then it wants to know how many minutes does it take to roll a lawn that is 120 feet long. So must be a rectangle, 120 by 75. All right, well, basically, I need to know what the area is, right? I need this in square yards. Unfortunately, this is in feet. So I should probably either multiply and then convert, but then that has to take scale factor into account. So perhaps, in order to make sure that I'm absolutely right, I should convert this into yards first and then do the multiplication. So these guys are in feet. There are 3 feet in 1 yard, so you can, if you really need to, do a proportion. 120 feet is how many yards? If 3 feet is 1 yard, so basically we're just dividing 120 by 3 and we get 40 yards, all right, which means that 75 feet is 25 yards. So I'm going to take 40 times 120, I'm sorry, 40 times 25, and that gets me 1,000 yards squared. And then to figure out how long it actually takes, I am going to have to use unit analysis, which is a very sciencey thing to do, but you know, science is nothing more than applied math. So 1,000 yards, I can roll in 1 minute. I can roll 125 yards squared. So my yards squared cancel. I basically divide 1,000 by 125, and I wind up with 8, and that is in minutes. So that's my final answer, 8 minutes. Is it exact or approximate? Well, did I have to round? No, I did not, which means that my answer is exact. All right, now we're going to talk about triangles. So I've got a base of a triangle. I know its area. I need to find the height. Well, I know that area equals base times height divided by 2. And so if the area is 216 and the base is 24, then I need to take that height and divide it by 2. So essentially, I've got 216 equals 12h, which means that h has to equal 18. So this was in square feet, that was in feet, which means that my answer is 18 feet. All right, example 6 is referring back to that previous one about rolling the lawn. And it says if the lawn is half as long and half as wide, then will it take half the time to roll? I want you to be able to explain this in class tomorrow. So I want you to think about that, and I want you to come up with an answer. Last problem. I've got a triangle, and it's got a base of 6 and a height of 2. So we can draw any kind of triangle we want. I'm going to draw a right triangle. So base of 6, height of 2. These are in yards, and we need to find its area. Well, area is base times height divided by 2. So my area is 2 times 6 divided by 2, which means my area is 6 yards squared. All right, now it also wants us to find it to the nearest square foot. So I want you to pause your computer right now and calculate it to the nearest square foot. Now many of you with good intentions will have said, all right, well I've got 6 square yards and there's 3 feet in a yard, so I'm going to take 3 and multiply it by 6, and so my area is going to be 18 feet squared. And you are wrong. Here's the reason why. All right, so I have 6 yards squared, and I want to know how many feet squared that is. So essentially what you did was you set up a proportion and you said there are 3 feet in 1 yard. But I cannot set these two equal to each other because their units are different. So in order to set them equal to each other, I have to square both sides. Well, I have to square this side to make them both squared. So essentially, I get 6 over x equals 1 squared is 1, 3 squared is 9. So what I wind up with is that x equals 54. So the right answer for the area in square feet is 54 feet squared. If you got that first try, congratulations. If you didn't, then you need to be very conscious of the fact that our units have to be the same in order to use our conversion factors. Also, you might want to memorize the ones that I've given you. Well, this concludes our notes for the first unit. Congratulations on having made it this far, and I will see you in class. Thanks.